Welcome to Algebra 1, Unit 7, Lesson 20 Practice Problems. This lesson has one vocabulary term, and that is quadratic formula. Quadratic formula is the method we will be using to solve quadratic equations. We need these quadratic equations to be in standard form, ax squared plus bx plus c set equal to 0. There's one rule, and that is that a cannot be 0, because if it was, x squared would go away, and this would no longer be a quadratic equation. The formula itself is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. When you find these solutions for x, what you are really finding are the x-intercepts. If you have any questions about the quadratic formula, please ask for clarification so that you are set up for success moving into the practice problems as well as the last test at the end of Unit 7. So on this first problem, we are going to decide whether each number is rational or irrational. A rational number can be written as a fraction. So a whole number fraction at that. So the first one is 10. 10 is the same thing as 10 over 1, so this is rational. The second one is 4 over 5. This is already a whole number fraction, so it is also rational. The next one is square root of 10. Now, a way to tell whether this is rational or not is to throw it in a calculator. Notice that the answer we get takes up every spot the calculator allows us to have. It never enters a repeating pattern. It never stops. The only reason it stopped at this last 7 is because the calculator only allows us to show that many numbers in the answer. So if it does not enter a repeating pattern and it does not stop, we will not be able to write it as a whole number fraction. So this would be irrational. Next, we have negative 3. Negative 3 can be written as negative 3 over 1. And since I can write this as a whole number fraction, this is a rational number. Next, we have the square root of 25 over 4. Well, the square root of 25 is 5, and the square root of 4 is 2. Since I can write this as plus or minus a whole number fraction, this is a rational number. And finally, we have the square root of 0.6. If we put this into a calculator, notice we get the same thing as when we did it to the square root of 10. I have a non-repeating decimal that does not have a stopping point. So this cannot be written as a whole number fraction, and it is an irrational number. If you have any questions about how to tell the difference between a rational number and an irrational number, please ask for clarification now so that you are best prepared as we move into the other practice problems. On our next practice problem, it says here are the solutions to some quadratic equations. Select all solutions that are rational. So, if we look at this, we have 5 plus or minus 2. Well, 5 can be written as 5 over 1, so it's rational. And 2 can be written as 2 over 1, so it's rational. If I'm adding or subtracting two rational numbers, then I'm going to get a rational number for my solution. For choice B, we have the square root of 4 plus or minus 1. The square root of 4 is plus or minus 2, which can be written as plus or minus 2 over 1, so this is rational. 1 can be written as 1 over 1, so it is also rational. And if I'm adding two rational numbers together, I'm going to get a rational number for my answer. C. We have 1/2 that is a whole number fraction, so that is rational. Then we have 3, which can be written as 3 over 1. So because it can be written as a whole number fraction, it is rational. If I add or subtract two rational numbers, I'm going to get a rational number for my answer. Choice D. 10 can be written as 10 over 1. Since it can be written as a whole number fraction, it is a rational number. Then we have square root of 3. If I put this into a calculator, notice I get a non-repeating, never-ending decimal. So this cannot be written as a whole number fraction, so this is an irrational number. If I try to add or subtract a rational and an irrational number, I'm going to get an irrational number. So D cannot be correct. Next, we have choice E, plus or minus the square root of 25 is plus or minus 5, which can be written as plus or minus 5 over 1. Because this can be written as a whole number fraction, this is a rational number. So E is a correct answer. Choice F. 1 can be written as 1 over 1, and since it can be written as a whole number fraction, this is a rational number. The square root of 2, if we put this into a calculator, notice we get a non-repeating, never-ending decimal. This cannot be written as a whole number fraction, so this is irrational. If I try to add or subtract a rational number and an irrational number, I'm going to get an irrational number as my answer. If you have any questions about how to determine whether numbers are rational or irrational, and whether their sum or difference is rational or irrational, please get clarification so that you are set up for success moving forward to the other practice problems. Solve each equation. Then determine if the solutions are rational or irrational. So on number 1, we're going to take the square root of both sides, and we have x plus 1 equals plus or minus 2. You subtract 1 from both sides, and x equals negative 1 plus or minus 2. So if you add x equals negative 1 plus 2, which equals positive 1. If you subtract, the negative 1 minus 2 equals negative 3. 1 is a rational number. Whole numbers are rational numbers. Negative 3 is also a rational number. Again, because whole numbers are rational numbers. They can be written as themselves over 1. Number 2. We're going to take the square root of both sides, and we have x minus 5 equals plus or minus 6. To get x by itself, we're going to add 5 to both sides. So we have x equals 5 plus or minus 6. If we add, then x equals 5 plus 6, which is 11, and whole numbers are rational numbers. They can be written as themselves over 1. If we subtract, then 5 minus 6 equals negative 1, which is a whole number, can be written as -1/1. So this is a rational number. Number 3. We're going to take the square root of both sides. So we have x plus 3 equals plus or minus the square root of 11. To get x by itself, we're going to subtract 3 from both sides. If we put the square root of 11 into a calculator, we get a non-repeating, never-ending decimal. So the square root of 11 is irrational. So these answers are irrational. And number 4, we have, once we take the square root, x minus 4 equals plus or minus the square root of 6. To get x by itself, we're going to add 4 to both sides. So we have 4 plus or minus the square root of 6. If we put the square root of 6 into a calculator, we get a non-repeating, never-ending decimal. So these answers would be irrational. We could not write them as whole number fractions. If you have any questions about how to determine whether solutions are rational or irrational, please get clarification so that you are set up for success moving on into other practice problems. The last practice problem on lesson 20. Here is a graph of the equation y equals 81 times x minus 3 squared minus 4. Based on the graph, what are the solutions to the equation 81 times x minus 3 squared equals 4? So here is where you need to remember solutions are x-intercepts. So the solutions are x equals 2.778 and x equals 3.222. Number 2, can you tell whether they are rational or irrational? Explain how you know. For number 2, they are rational because repeating decimals can be written as whole number fractions. 2.778 is just where they rounded using the next 7. This is really 2.777 repeating forever. 3.222 is obviously a repeating pattern decimal. These repeating pattern decimals can be written as whole number fractions, so they are rational. Number 3, solve the equation using a different method, meaning a method other than graphing, and say whether the solutions are rational or irrational. Explain or show your reasoning. So I'm going to take this very equation that they graphed. (81 times x minus 3 squared equals 4. And I'm going to divide both sides by 81. Now this is going to give me x minus 3 squared equals 4 over 81. I would take the square root of both sides and get x minus 3 equals plus or minus, the square root of 4 is 2, and the square root of 81 is 9. To get x by itself, I would add 3 to both sides. So I have 3 plus or minus 2 over 9. 3 is rational. 2 over 9 is rational. That means 3 plus or minus 2 over 9 is also rational. If you have any questions about how to determine whether answers are rational or irrational, please ask for clarification so that you are set up for success on your end of Unit 7 test. There is going to be this material on the test.